once we have the hardware user manual ready, like it's downloaded now, so what we need to do, we need to go to the clock, basically clock chapter. So this is the one, chapter 5, clock generator. We are going to come to the internal block diagram of the clock. That is what I want to explain it to you over here. So yeah, we'll have to go to it. Yes, so now we are capable of seeing how the internal structure is of the clock tree. Basically, this is called the clock tree. So this is where the MCU core is basically present, and whatever clock is going to come, that clock is basically going to run the MCU, the what do you call the ALU, arithmetic logic unit, and CPU, the core we are talking about, right? So to select which clock is going to come over here, we have this bigger block coming over here. Okay, so this bigger block most of the time is the one that is basically used to source the clock of the CPU. Hence we are going to understand what are the options that we get to for this block to get the clock from. Okay, so we will zoom in little more. So there are basically two options. One is this black dark line, and the other one is this black dark line. Okay, so talking about the first one, so this is called high speed system clock oscillator. So what it basically is, it is basically connected with external two pins, X1 and X2, or you can name it as P121 or P122. So if you have a crystal oscillator of up to 20 megahertz, you can place it over here on X1 and X2 with some 22 microfarad or up to 33 microfarad capacitors. There will be picofarad capacitors that can be placed over there, that we can discuss in the schematic afterwards. Okay, so this video is related to the programming, so let's stick to it. So you can place the external oscillators on these two pins. Okay, or if you have an external oscillator giving you PWM signals, you can place it on this pin, the X2 pin, and that is going to come. So one option is this, and the other option is basically the high speed on chip oscillator. So we have two options, external crystal or the internal high speed on chip oscillator. Nothing has to be put on the PCB, it is already present inside your MCU. So the frequencies that you get the option from are 64 megahertz to 1 megahertz, 1 being the least and 64 being the highest. So what happens is that the main system clock can never be 64 megahertz, or I'll rephrase that, it can never exceed the value of 32 megahertz. So if you happen to choose 64 megahertz, it will automatically be divided by 1 by 2. Okay, and you will be getting 32 megahertz to run the main system clock. Or if you select 48 megahertz, it is going to be divided by 1 by 2, and what you will be getting is 24 megahertz. If 32 you have selected, it will directly go. So it goes from this path then. Okay, yeah, the reason why 64 was present was that your main core is going to run on 32 megahertz, but your timer RX and your timer RD can still work on 64 megahertz. So that was the reason why this concept was there, and it is getting divided. The core is on 32, and it can be the timers can exceed that frequency. So that is some concept of it. Okay, so these are the two options that you are getting to run the main system clock. Then similarly, we are having again a separate clock mechanism to run some specific peripherals. The main important peripheral will be real-time clock or the watchdog timer. These are the two important peripherals, the secondary peripherals. Okay, so for these peripherals we are having a separate source. Now again, for this source we are having two options. One option is low speed on chip oscillator, that is of 15 kilohertz, very similar to the this one on chip oscillator, but it is only 15 kilohertz. Okay, but if your application requires use of RTC and the accuracy of RTC means real-time clock, if it really matters, then I would recommend you to use a crystal of 32.768 kilohertz, because that's a dividable frequency and you get a better accuracy in the RTC. So this is the crystal that is supported over here. This is the only value of the crystal that is supported over here. That's the right sentence.